All right, here's 8-2. Just going to take a single day on it to introduce and practice with the law of cosines, which I'm kind of cutting out on the right side over here. We'll be sure to get the whole thing in. It's got a lot of different forms here, and at first glance can kind of look confusing, okay? But here's what's going on with the law of cosines. It doesn't do anything different from the law of sines, okay? It finds side lengths and angle measurements that, are a part of a triangle. Again, doesn't have to be a right triangle, okay? This first set right here, these are all about finding sides. These are the same equations rearranged, but you would use that form if you are looking to find an angle, not a side, okay? Notice in the diagram over to the left, with the angle and the opposite side lining up, it still goes off of the same way we would label a triangle as we did with the law of sines. That's all the same, okay? You're only ever going to have one triangle possible. And it can round to the nearest hundredth, okay? So you might be kind of wondering, like, okay, law of sines was fine. It was working great for us. What's the issue here? This is actually where cases become a little bit more important. We talked about them with the law of sines, but it was basically, other than like the side angle case, if that wasn't going on, it kind of didn't matter, Now it really does, okay? Because you'll notice these two cases, side angle side would be something like this. You've got side A, side C, and angle B, okay? Two sides and an angle in between. We can play around with this in class if you need some convincing, because I think it's good to want to check. For the side angle side case, the law of sines won't work, okay? You can't set up the ratio that you need with like knowing 3 of the 4 missing pieces of information. Side would be, you have side A, side B, and side C. Okay, no angles, which we could then find with the law of cosines, but it's another case where you would find the law of sines. It's not going to work, okay? So that's really where the law of cosines becomes important, and the cases become important because now you've got these 2 different sets of possibilities with the law of sines and cosines, and the case that you have determines what approach you would take. Okay, so I'll show you here in the next couple slides one of each, a side angle side and then a side. Actually, flip that. We'll do the side first. Okay. Really doesn't matter which approach you want to take first. Okay, I'll just say right here, we'll go B. So I'm finding an angle, so I'm using the form that was over on the right side, okay? Now, the way I'd set this up is 6 squared plus 8 squared minus 12 squared. And the way I kind of remember this is 12 is the side that is opposite of B. It's right over here, okay? That's the one that gets subtracted at the end. And it's actually the only time it shows up, because everything else is off of the other 2 sides, right? Just for having labels with these side length that's 6, we'd call A, and side length that's 8, that would be C, okay? We'd simplify the top and the bottom and get negative 44. And then to get to angle B, we would take the inverse cosine of negative 44 over 96. Now, I didn't mention it earlier because it shouldn't be a change, but we're always in degree mode. But if you've been working with like your own personal calculator, that shouldn't change, right? You've been working with degrees the whole time with the law of sine, so that's not a change, okay? All right, so B is 117.28. Let's do cosine of C, okay? Now this would be set up 6 squared plus 12 squared. Now the minus is 8, okay? And that's coming from the fact that here's angle C. The one I subtract has to be the side that's opposite. And that's the only time you'll see 8. This would be over 2 times 6 times 12. Top would be 116, bottom would be 144. Time for an inverse. Which you should get 36.34, okay? Now, I'm a little low on room, okay? But I think it's worth noting if you'd wanted to practice with the law of cosines, again, you could do it, right? All that's left is angle A. However, I think it's just fine with us to take the approach of, all right, 180. Right here, let's put our work down here to get angle A. At this point, we'd say 180 minus 117.28 minus 36.34, which should get you 26. Let me just check on my, I want to see 26.38, but let me check. Yep, 36.38. Now, I didn't show you here, but again, if you wanted to set it up to find cosine of A, we could have done that. We could have just done the law of cosine 3 times. I think this is the more practical way to do it, that you do the law of cosines twice, and then again, to find a missing angle, if you have 2, using the fact that they have to add up to 180, probably the easiest way to do it. Now, I didn't mention my case up here. Like, I kind of did. I didn't write it out. This case is known as side, side, side. Okay? All 3 sides didn't have any angles. Whoops. Here is the SAS. Side, angle, side. 2 sides and an angle in between. Okay? Another case where the law of sines won't work, okay? You can give it a try if you want to. It's not going to happen, okay? First thing I'm going to do is get side length A, which would look like this. Okay? The formula will actually get us A squared. So I'd have 12 squared plus 16 squared minus 2. Right? Now, if you're going really, really closely off the formula and it's like plugging in letter for, like number for letter, 12 is B, 16 is C. and then cosine of 80. That whole right side would simplify to a single number. You could throw that all in your calculator at once if you wanted to. That would be a good way to do it. And there is side length A at 18.26. Okay? Really, if you pick the right form of the law of cosines and you can get the numbers plugged in, your calculator kind of takes it from there. And that's really all about, you know, all you need to do. Okay? Get everything, get the right formula, get everything plugged in. All right, so there we go. We got a missing side, right? We got A. We still got two angles missing. I'm going to go get B. So the cosine of B, I got to use my new one. $18.26 plus 16 minus 12. And again, the way I remember that is B is, side length B is 12. That's the one that's opposite. I know that one is the one I minus at the end. That's the only time 12 shows up because it also doesn't go on the bottom. Okay. Now I'll get some decimals here, but you should find that top would simplify to 445.43. We'll keep rounding to the nearest hundredth. And 584.32. And we are very close. That fraction that we got with these two decimals, we just have to take inverse cosine of that on our calculator. And we are good to go, 40.33. Okay, and again, that was angle B right up here that we got, okay? Which leads us to the same situation we've been in before. We have angle C left. Okay, we can kind of take a couple different approaches. If we wanted, we could do the law of cosines again. Okay, but again, I'm showing you here in the notes the way I think, if it were like a test question, this would be the way to do it. The law of cosines would work, right? But the number of examples you have is adding up here. So in your notes, I think you're good on having plenty of them. And I think it is really important to recognize when you have two of the three, the most efficient way to get your third is just to subtract the two you know from 180. Right, the math involved is a little bit simpler and it's more efficient to just take away those two you know. The missing one would be 59.67. If you went through and used the formula for cosine of C that you got on the first slide, you'd get the same thing. We might have a little bit of rounding error that would differ, but you should get something right in the ballpark of 59.6 degrees. All right, we'll throw in an application problem here. Get us one more example. So here, when I was talking about I really like, if I'm going for an angle, which we are here, to kind of recall where the side length that's opposite goes, okay? I like it for this case, okay, because I get an application problem and all the sides aren't labeled like they have been in the others. Now, if you wanted to, you could, okay? If you want to say, we're looking for A, this is angle B, this is C, therefore this is side length A, here's side length B, side length C. You can do that, okay? As long as you're consistent with opposite side, opposite angle, that's going to work, okay? I am going to do it without it. The angle I'm looking for is right here. So I'm going cosine of theta, right? And this is where I remember 376, or the side that's opposite, should only come up once, okay? Should only come up one time. I go 289 squared plus 235 squared. And that's where I put that minus 376. And again, it's the only time it shows up. 2 times 289. Times 235. The top will simplify to negative 2,630. Bottom, you should get 135,830. We'll take the inverse cosine of that. And we get about 91.1 degrees. Okay? Same law of cosines, right? And I know you might be a little freaked out that I just used theta. Again, it might be if you're kind of like, yeah, I kind of see what you did, but I'm still kind of concerned, would I pick out the right formula and get the numbers put in where they go? If that's the case, then I would say go back here, and this might be a good thing for you to do, is to say, I'm going to call it A, here's A, angle B, angle C, side C, right? You may want to take a word problem and use the letters that go with the diagram and the original formulas that we got on the first slide, right? Because you set it up that way, and you're like, yeah, here's A. This would be cosine of A. That's what I'm looking at. That's what I'm looking for. C, B, C, and B. Okay? That would work. Okay, so feel free to add, I mean, as long as you're consistent with opposite side, opposite angle, label it yourself if you'd like. Well, this is a little odd. I switched my slide. I don't know if you're seeing the same thing, but my solution won't go away. And I liked it, you know. I solved for that missing angle between those two planes, but, you know, I don't want it anymore. So I got to get him. Got to get him out of here, and then bear with me here while I erase my life away. I mean, not really, but not really erasing my life away, but just erasing a lot on my little video here. Almost done. All right, here we go. Kind of the same in 8-1, day 2, where we're going to finish with sort of a, not random, it's another area formula that I just keep throwing these new ways to get areas of a triangle. They kind of fit the pattern of kind of what we did in that particular lesson. Back in 8.1, I showed you the area formula that had sine in it, like 1/2 AB sine C. It kind of went with the law of sines because it's, you know, it's based off the sine function, okay? This one's not based off the cosine function, but the deal is it offers a way to find area if we have a side, side, side case. By the way, I'm not going to do this problem. Okay? If you're just given the 3 sides, it's possible to find area, right? And that's kind of these new formulas that we've been using. That's sort of what they're about. Is we're used to like 1/2 base times height, and now we're like, no, we could, like, if we had a triangle where we didn't have the height, right? We just had 9, 8, 5. It can be done, right? We don't need the height. Okay. So Heron's formula says you need to find this number called S, which is the 3 side lengths all added up and divided by 2. So easy enough. 5 plus 8 plus 9 all divided by 2 would be 11. Okay? So notice this formula uses the number 11 quite a bit. All right, the square root of S, well, S is 11. Now, I probably should get some labels on here, right? And it doesn't really matter. I just need one of each, right? So let's say A is 5. Let's say B is 9. Let's say C is 8. Okay, that'll do the trick. Okay, so 11 minus A. 11 minus B, 11 minus C. All right, 11, let's see here, times 6, times 2, times 3. I'll check my numbers here. I believe that all comes out to be 396. Yeah. Take that square root. And we get about 19.9 feet squared. Okay? Call that Heron's formula. Again, we lumped it down with the law of cosines because it fits a similar case. If you just have all 3 side lengths, we can get the area of a triangle. That's what it would look like, and that's how it's done.